Hi there, folks. This is the Practice Chapter 9a test, and as always, I am the amazing Mr. Jansen. So away we go. If we take a look at these first couple, we just want to simplify the expression. This first one, we're going to simplify using our rules of exponents. And the first thing we have to do is raise this thing to the 8th power. So I'm going to leave the x to the 10th alone for right now. When I raise two things to a power, I multiply the exponents. So that's going to give me an x to the negative 24th. And now I'm going to take care of this multiplication. When I multiply two things, I add the exponents. That's going to be an x to the negative 14th. And now negative exponents, I don't typically leave as negative exponents. I'm going to rewrite this as 1 over x to the 14th. Okay? For the next one, I'm just multiplying two binomials. And for this, I'm going to either FOIL or just think of it as my distributive property. So I distribute the 2y to each term in the second polynomial. That's going to give me an 8y squared plus a 2y times 3, which is 6y. And now I'm going to distribute the negative 5. Negative 5 times the 4y is a negative 20y. And then a minus 15. And then the last thing I do here is combine like terms. I have some like terms right here. That's going to be an 8y squared. That's a minus 14y. And then the minus 15. And that's it for that one. For the next one, I have to break this into perfect squares. So I want to find the largest perfect square that divides evenly into 32. And for this particular example, it's 16. I can break that into 16 times 2. For exponents, exponents are perfect squares if the exponent's divisible by 2. Remember, I'm just dividing each by 2 when I take the square root. So x to the 10th is already a perfect square, and so is y to the 2nd. So now I start taking the square root of each. The square root of a 16 is a 4. Goes to the outside. Is a change number on the outside. The square root of x to the 10th, we divide the exponent, so it's x to the 5th. It's a changed variable on the outside. And then the square root of y squared is just a y. And now what I'm left with under my square root, the only thing that's left is the 2. And that's it. In number 4, it asks us to find the domain. And remember, for a square root function, the thing I cannot have with a square root is a negative under the square root, which means the radicand here, which is the 2x minus 6, the 2x minus 6 has to be greater than or equal to 0. That's the mathematical way of saying that it can't be negative. And now I'm just going to solve this for x. So I add the 6 to each side. That gives me a 2x is greater than or equal to a positive 6. And now to finish solving this, I divide each side by 2. So when I do that, I find out that x is greater than or equal to a positive 3. And then for my notation here, remember I say that the domain is x such that x is greater than or equal to 3. And that's it. In number 5, it asked me to find x if the average of these numbers and x, including that as one of the numbers, is 16. So I'm just going to set this up. When I take the average of something, I add up all the values I have, the 20 plus the 20 plus the 19 plus the 13 plus the x. I have to include x as one of my values. Okay, even though I don't know what it is yet, I still have to include it as a value. I'm going to divide by how many I have. And again, since I included x, it's 1, 2, 3, 4, 5 values. And that's how I find the average. And it's telling me that the average is 16. So I set this equal to 16. And now I just have to simplify this thing. So I'm going to add the like terms up in the numerator. And that's going to give me a 72 plus x all over 5. And now I could approach this a couple ways. I could cross multiply or just multiply each side by 5. I'm going to multiply each side by 5 to get rid of the fraction. Whatever I do to one side, I have to do the other side. Over here, the 5's cancel. Let me rewrite this. That's a 72 plus x equals an 80. Okay, because it's 16 times the 5. And now to finish solving this, I'm just going to subtract the 72 from each side. And I find out that x equals 8. Okay? In number 6, it says match each function to the transformation of the function y equals x squared. And we talked about these transformations in the last chapter, but they apply to any function. So when I'm looking at this, remember when I add on the inside or subtract on the inside, it moves it left and right, but it goes the opposite direction I might think. So subtracting on the inside is going to move it to the right that many units, which is letter C. So it's going to shift to the right 3. Adding on the outside of the x value is going to move it up and down, and that moves in the direction we would think it would. So that one's going to go up 3. Adding inside with the x, if I add to the x value itself, that's going to move it to the left. Subtracting on the outside moves it down. And then multiplying, changing the a value, doubles all the y values. That's letter E. So it's the exact same thing we did with our square root functions, except now I'm applying it to a squared function, okay, to a quadratic. In this one, it's asking me about the a value. Remember, we have a couple of things that the a value does. It makes it skinnier or wider because it changes the height of this thing, but it also affects whether this thing opens up or down. When the a value is greater than 0, in other words, when the a value is positive, when this one is positive, it's a happy parabola, so it opens up. When the a value is less than 0, so right here when the a value is negative, it's a sad parabola, so that opens down. Remember, positive is happy, negative is sad, so that tells us whether it opens up or down. And it has a very similar effect, and we can think of it this way when we talk about the vertex as a maximum or minimum, like we're going to talk about in these next couple problems. If the a value here is negative, negative a value means it opens down, which puts my vertex at the top, right? So that would make this a maximum. All right, so the vertex being at the top is a maximum. So that one's kind of reverse what we might think. When it's negative, it's a maximum. When it's positive, it's a minimum. All right, the next one, again, this is positive, means it opens up, which means my vertex is at the bottom. So this one's a minimum. The next one is positive. So once again, that opens up. Vertex is at the bottom. So that's a minimum. And then the last one of these, the a value is a negative, which means this opens down, which means my vertex is at the top, making it a maximum. Okay, and it's important to understand that relationship because it helps us graph certain things much quicker. Okay. For the next couple, I want to decide how many solutions it has. And really, if I'm deciding how many solutions it has, I'm looking for the x-intercepts. So there's a couple ways you can approach this. You can either solve this and try to find the solutions. Like for this first one, if I did the x squared minus x minus 6 equals 0, I built a bridge and I solved by factoring to x minus 3 and x plus 2. And then set each factor equal to 0. I'm going to find the two solutions of x equals 3 and x equals negative 2. So that's one way of knowing that it's two solutions. I could also think of it in terms of graphing. If I found the vertex for this one, the vertex is going to be down here somewhere, and I actually drew the parabola, I'd find out that it crosses the x-axis in 2 places, okay? And that would make this to have two solutions also, because remember, solutions and x-intercepts are the same thing. For the next one, again, I could set this whole thing equal to 0 and solve it. I can multiply each side by 2. That's going to eliminate the fraction, which gives me x squared equals 0. And really, I would probably just take the square root of each side. And when I take the square root of each side, I always do plus or minus, but plus or minus 0 is just 0. So really, I only have one solution for that one. I can see it. But also, again, if I graph it, this thing's going to have a vertex of 0, 0, and it's going to open up. So the only place it touches the x-axis is at that vertex, so it only touches at one spot, which means it has one solution. And then this last one, if I were to set this guy equal to 0, the 5x squared plus 10 equals 0, if I divided each side by the 5 to start, that would be a good place to start this one. X squared plus 2 equals 0. I can't factor this thing. There's nothing I can do in the way of factoring here, so I would have to subtract the 2 from each side, which would give me x squared equals a negative 2. And you can already see what's going to happen here when I try to take the square root. I can't take the square root of a negative, so that gives me no solution, which is letter A. Okay. The other way to look at this is, again, I could find the vertex, and the vertex would be up here somewhere, and this thing would open up, and I can see that it doesn't cross the x-axis at all. All right, so those are the two ways to think about this. Check to see if you have x-intercepts, check to see how many there are, or actually just try to find the solutions, okay? This one, it says to give the equation of the axis of symmetry of the following function. So for this one, I want the equation of the axis of symmetry. Remember, the axis of symmetry is always x equals the x value from our vertex, which we find by doing the opposite of b over 2a. So now I'm just going to plug this in. The b value is right here. It's a negative 12. So the opposite of that would be a positive 12. The a value is right here. It's the negative 3. So 2 times the negative 3. And now I just plug it in. That's 12 divided by a negative 6, which is a negative 2. So my equation is x equals negative 2. And it is important to have the x equals because this is an equation of a vertical line. For number 15, it asks me to order these, place these in order from widest to narrowest. And remember, that's just dependent on the a value. That's when we change it from like a whole number to a fraction. Remember, the smaller the fraction, the wider the parabola. Okay, the larger the number, the skinnier the parabola is, or the narrower it is. So the smallest fraction I have here is this last one. So that's the y equals 1/4 x squared. Then the next smallest fraction I have is the one that has the 1/2. And again, this only goes by the a value, x squared. The next smallest value is the 4. So as we increase these numbers from something like 4 to 5, it's going to get more narrow. And then the last one I have is the 5. So essentially, I'm just listing these a values in terms of smallest to largest, ignoring any kind of negative signs that we might have. Okay? And that's it. For this one, it says to find each value. We're just going to look at the graph and find each value. So the vertex is always the maximum or minimum value. That's right here. And that is the ordered pair 1, 4. So it would just be 1, 4. And we want to know, is it a maximum or minimum? If we look, the vertex is at the top. So that means this one's going to be a maximum. For solutions, remember, solutions are the same thing as the x-intercepts. So I have one right here at negative 2. I have another one right here at positive 4. So my two solutions are x equals a negative 2 and x equals a positive 4. And now domain and range. When you think about domain, domain is like passing a vertical line over this thing. If I grab a vertical line here real quickly. If I take a vertical line and I drag it over my function, where's it going to touch? And keep in mind that these arrows mean this extends forever in each of these directions. So my vertical line is always touching the parabola, which means my domain is all real numbers. Okay? And again, I can write that this way. I can say x such that x is all real numbers. And that's my symbol for all real numbers. Okay, it's like an R with a bar added to it. And then the range is very similar. I would take a horizontal line. It's like a y equals line. And I would pass it over the function. If we look, it touches the parabola everywhere down here, but it doesn't touch the parabola up here. Okay, so my y values that are included start here at 4 and go to everything below that. So I would say that y is less than or equal to a positive 4. And again, in my notation, it's y such that y is less than or equal to 4. And really, that's review from previous sections that we've done, grabbing the domain and range from the graph. Okay? For this one, it says to give the coordinates of the vertex. So for the vertex, to find the x value for the vertex, I have to do the opposite of b over 2a. So that's going to be a negative 32 over 2 times 4. Again, it's always a, b, and c as my coefficients. And now I just have to plug this in, and it tells me, well, it doesn't tell me whether or not I have to leave this as a fraction or a decimal. So I'm just going to go ahead and plug it in. Oh, this one's going to work out okay for us. So negative 32 divided by 8, which is a negative 4. And now I just have to plug that back in. 4 times the negative 4 squared plus 32 times the negative 4 minus 25. And whenever you plug this in, use parentheses to plug these things in. And it looks like I get a negative 89. So my vertex is negative 4, negative 89. And that's it.